I welcome you all in this session. Today we will construct a deterministic finite automata which accept set of all strings over 0, 1 which when interpreted as binary number divisible by 2. So first we will find the sigma here, that is 0, 1. Now we will construct the deterministic finite automata that will accept these language. So here first we will focus on the input string. So these are the input string that we have to accept, and these are the input string that we have to reject. So we have to design a DFA which can accept these strings and which can reject these type of strings. So we can say this input string, when interpreted as binary number and converted to decimal and divide by 2, gives 0 as remainder. Similarly, this number 0010 is equivalent to decimal number 2 and it gives 0 as remainder when divided by 2. Now this input string, when interpreted as binary number and converted to decimal number, that is 1, gives 1 as remainder when divided by 2. Now this number 0011, it is equivalent to decimal number 3 and it also gives remainder as 1 when divided by 2. So we have to design the DFA that will reject these string and that can accept this type of strings. So we will check using this input string. So first we will check for the first input, that is 0000. So from state A, on input first 0, our next state will be A. On input second 0, our next state will be A. On input third 0, our next state will be A. On input fourth 0, our next state will be A. So our next state will be A on input 0000, and we have to accept such type of strings. So we have to make this state A as final. Now we will check for the input 0001. So on input 0, from state A, our next state will be A. On input second 0, our next state will be A. On input third 0, our next state will be A. Now on input 1, our next state will be B. So we have to reject such type of string. So our state B should not be a final state, so that we can reject such type of string. Now we can cross check using the third input string, that is 0010. So now on input 0 from state A, the next state will be A. On input second 0, our next state will be A. On input 1, our next state will be B. On input 0, our next state will be A. So our next state will be A, and A is a final state. So this string will be accepted. Now we will check for the fourth input string, that is 0011. So from state A, on input 0, our next state will be A. On input 0, our next state will be A. On input 1, our next state will be B. On input 1, our next state will be B. And B is a non-final state. So it will be rejected. So this DFA fulfills our requirement. So this will be a minimal DFA that can accept the given language. So this is all from my side for today's session. Thank you for joining.